In this lesson, we will derive all 6 of our trigonometric functions. So this lesson will be very foundational for all the work that we're going to be doing for our course. To get us started, I want to remind us of the Pythagorean theorem, very famous theorem. Given a right triangle, the sum of the squares of the lengths of the legs is equal to the square of the length of the hypotenuse. Many people know it as a squared plus b squared is equal to c squared. We're going to be using the Pythagorean theorem to derive a very important formula called the distance formula. Now we have this right triangle in the rectangular coordinate system in our plane, and the horizontal side of this right triangle has length x sub 2 minus x sub 1. That's the length of this leg. And the length of this vertical side here is y sub 2 minus y sub 1, basically the difference between the y coordinates. And the question is, what is the distance between point P and point R? What is the distance labeled d? Well, we can use the following. We can use the Pythagorean theorem to say that d squared is equal to this leg squared plus this leg squared. That's what the Pythagorean theorem says. So we have d squared here is equal to this right expression. So solving for d, we can say that d is equal to, now this is the distance formula, d is equal to the square root of the sum of the squares of the difference of the x coordinates and the square of the difference of the y coordinates. Now this is very important that in our plane, the distance between any 2 points in our plane, the distance between any 2 points in the plane can be found using the distance formula. Again, the distance formula says that the distance d here is equal to the square root of the sum of the square of the difference of the x coordinates and the square of the difference of the y coordinates. Now you may want to make sure you remember this formula really well, because we're about to define all of our 6 trig functions and we're going to be using the distance formula to help us do that. Okay, so remember this formula really well. All right, here we go. Now, to define the 6 trig functions, we start with an angle. I'm going to label my angle or name it theta. And notice that this angle theta is in standard position. Now, we talked about this in an earlier lesson, that an angle in standard position means the vertex is at the origin and the initial side lies along the positive x-axis. So it's very important that you understand that this angle is in standard position. That is to say, our six trig functions will be defined by an angle in, or by angles in standard position. Okay, what we're going to do now is we're going to choose any point. That's also very important. Choose any point, let's call it point P, on the terminal side of our angle theta. Okay, any point we want on the terminal side. I should say any point except for the vertex. Let's not choose the vertex, which is at the origin 0, 0. But any other point other than the vertex, any other point, and let's call it point P. And let's just say point P is right around here, and it has coordinates x, y. Now what we want to do at this point is draw the perpendicular from point P to the x-axis. So something like this, the perpendicular right here to the x-axis. Let me show you that it's a perpendicular, so there's a right angle there. And the point at which the perpendicular meets the x-axis, let's call that point Q. So now we have a right triangle. We have a right triangle having vertices at O, which is for the origin here, P, and Q. So this is our right triangle. Okay. What we want to do is find the distance R This distance will be labeled r, the distance from P to the origin. From P to the origin. Let's label that r, and that's what you and I want to find using the distance formula. Now the distance formula says that the distance, this is the distance between O and P. The distance between O and P, that means this distance from O to P, is the square root of, now you've seen this formula before, right? This is the distance formula that you and I proved earlier. So the distance between O and P is exactly what we call R. Okay? And what we want to do is get the distance between O and P. All we have to do is find the difference between the x-coordinates. The x-coordinate here at P is x, and the x-coordinate here at the origin is 0. So this is going to be x minus 0. That's what this is going to be, x minus 0 squared, plus, now we got to do the difference between your y-coordinates. The y-coordinate at P is y, and the y-coordinate at the origin is 0. So it'll be y minus 0. And then quantity squared, don't forget the square root of all of this. Okay? So basically, if we simplify, r is equal to the square root of x squared plus y squared. Okay? Now this is really important. It's important that you understand what r represents. R represents the distance from the origin, or from the vertex, which is at the origin. So it's the distance from the vertex to the point that you and I chose on the terminal side of our angle in standard position. Okay, so that's what this represents. Now, let's talk about our 6 trigonometric functions of angle theta. The 6 trigonometric functions of angle theta are the following: sine, cosine, tangent, cotangent, secant, and cosecant. Let me write those down. So here are the 6 trig functions that you and I will be studying in this course, and these are the abbreviations. So we will hardly ever write out the functions entirely. Most of the time we'll be using their abbreviations. Okay, so let's actually define what these functions are, or how they're defined for an angle theta. Now remember, theta is an angle in standard position, and remember that r represents the distance from the origin to the point on the terminal side, okay? And r is equal to, that distance is actually equal to the square root of x squared plus y squared, okay? Now don't forget, in this diagram up here, let me show you, in this diagram, this distance here, ladies and gentlemen, represents x, and then this distance here represents y, okay? So when we say r is equal to the square root of x squared plus y squared, this is what is x. This horizontal distance is x, and this vertical distance is y, okay? All right, let's go to the formal definition for our 6 trig functions. All right, here it is, everybody. This is one of the most important definitions that you and I will write down in our class, and this is a definition for our trigonometric functions, all right? Let x, y be a point other than the origin on the terminal side of an angle theta that's in standard position. The distance from the point to the origin is r, which is equal to the square root of x squared plus y squared. The 6 trigonometric functions of theta are defined as follows. Sine of theta is equal to this ratio, y over r. These are 2 distances. Remember, everybody, y is that vertical distance in our triangle that I showed you earlier. And r, well, I showed you what that r is representing, right? R is representing the distance from the origin to the point on the terminal side. So sine of theta is basically this ratio. Cosine of theta is x over r, tangent of theta, y over x. Here we have to make sure that x is not 0, because if x were 0, then this function tangent would be undefined. Cosecant of theta is r over y. Notice that it's the reciprocal of sine of theta. Cosecant of theta is r over y. Make sure y is not 0 or else cosecant is undefined. Secant of theta is r over x. Please notice that it is the reciprocal of cosine of theta. X must not be 0 or else secant of theta is undefined. Finally, cotangent of theta is equal to x over y. Y must not be 0 or else cotangent of theta is undefined. Please, please, I implore you to make sure you know these ratios really, really well. Sine of theta is y over r, cosine of theta, x over r, tangent of theta is y over x. I think if you know these three really well, and then just remember that these three are just the reciprocals of the first three, I think that would be great. All right, let's work on some examples. All right, here we go. Example 1, the terminal side of an angle in standard position passes through the point 12, 5. Find the values of the 6 trigonometric functions of this angle. Maybe we should call this angle theta, all right? Angle theta is in standard position. All right, everybody, the fact that they told you that this point, or this angle rather, goes to the point 12.5. Let me, if you don't mind, can I give you a visual to view? I know a lot of you are visual learners, so I would love to give you something to look at. Okay, a lot of people understand better if you can give them a picture to look at. All right, so I'm going to draw you an angle in standard position. Now remember, standard position means the vertex is at the origin and the initial side lies along the positive x-axis. Now this terminal side goes through the point 12, 5. So then it is something like this, okay, everybody? The terminal side goes right through the point 12, 5, okay? So then this would be theta right in here, okay? This would be theta right there. All right, everybody? So we are finding the 6 trigonometric functions of this angle theta. Now, when they give us the point 12, 5, 12, 5, let us not forget that 12 is your x value and then 5 is your y value. Also, don't forget that all of your 6 trig functions, all of them, are defined by ratios between 3 different distances, x, y, and r. We know what x is. It's 12. We know what y is. It's 5. What we do not know at the moment is r. And this would be r right here, everybody. The distance from the origin to this point, 12, 5. Okay? So, in order to find r, we can use this formula, right? R is equal to the square root of x squared plus y squared. Remember that from the definition. So then, in this case, r is equal to the square root of 12 squared plus 5 squared. That is, r is equal to the square root of 144 plus 25. R is equal to the square root of 169. So r is equal to 13. So what I can do is I can take my x value, I can take my y value, and I can take my r value, and I can now say what the 6 trigonometric functions of angle theta are. Let's do it now. All right, here we go. Sine of theta is going to be y over r, so 5 over 13. Cosine of theta is going to be x over r, so 12 over 13. Tangent of theta will be equal to y over x, 5 over 12. Now the next 3 trig functions are reciprocals of what we just wrote down. So if you get these 3 correct, the next 3 should be correct as well. Cosecant of theta is r over y, so it'll be 13 over 5, or just the reciprocal of what we wrote down for sine of theta. Secant of theta will be r over x, 13 over 12. That is to say the reciprocal of cosine of theta. Cotangent of theta, the last one, will be x over y, so it'll be 12/5, basically the reciprocal of tangent of theta. These are the 6 trig functions of this angle theta. Now we're done, but I want to highlight something. When you are writing down your work, make sure, now this is a very common mistake, so hear me clearly, make sure you do not forget to write down your argument. Your argument is theta, right? We learned in our algebra studies that every function must have an argument, right? Like you studied f of x. F is the name of the function, and x is your argument, right? Maybe I should write this down. When you had something like this, f of x. F is the name of the function, x is your argument, right? Or your input. So sine is the name of the function, and theta is your argument. Theta is your input. So be very careful to not write sine is equal to 5/13. No. It's sine of theta is equal to 5/13. This is really important. Make sure you do not have, this is what I see a lot, unfortunately. I see a lot of this, everybody. You see what I just did there? I see this a lot. Cosine is equal to 12/13. Cosine of what? So you have to make sure you say cosine of theta is equal to 12/13. Do not forget the argument, okay? All right, good work. Let's move on to another example. Okay, the terminal side of an angle in standard position passes, sorry about this, it's not passes to the point, it should be passes through the point, typo. Passes through the point 8, -6. Find the values of the 6 trigonometric functions of this angle. Again, let's call this angle theta. We don't have to keep using theta, by the way. You can use alpha, beta, gamma, any other Greek letter that you know, or you can use, letters of our alphabet as well. You can call the angle A or call the angle B or whatever. All right, what I would invite you to do is pause the video right here, please. Pause the lesson, and can you work out this example on your own? This example is very, very similar to the previous problem, okay? Can you do me a favor? When you pause the video, the first thing I would ask you to do is actually draw this angle like I did. Can you draw the angle and then do the work? Go ahead and do that now. All right, let me check in with you now. This is my diagram for the angle theta. I do have the angle opening counterclockwise, a positive measure here, and it's going through the point 8, -6, which is in quadrant number 4. This is my distance y, and this is my distance x. I did draw the perpendicular from the point on the terminal side to the x-axis. I feel like I did a better job at showing you a more accurate diagram than I did in the previous problem. All right, here they gave you this point 8, -6, so we do know x is 8 and y is -6. Using this formula that r is equal to the square root of x squared plus y squared, we can find that r is equal to 10. Now that we know x, y, and r, we can now answer the question. All right, we have sine of theta is -6/10. Please simplify it as -3/5. Cosine of theta is 8/10. Simplify it as 4/5. Tangent of theta is -6/8. Please simplify it as -3/4. Now the last three are the reciprocals of what we just said. So I just took the reciprocal of -3/5 and got -5/3, and then 5/4 and -4/3. Remember, we're getting these values from the definition of the 6 trig functions. Remember, sine of theta is y over r, cosine of theta is x over r, tangent of theta is y over x, and so forth. All right, good job, everybody. All right, everybody. I hope to prove right now that we can find the 6 trig functions using any point other than the origin on the terminal side of an angle in standard position. Remember, I just said that you can choose whatever point you want on the terminal side of your angle in standard position to generate your 6 trig functions. Any point you want, as long as it's not the origin, choose any point you want. Your trig function values will be the same no matter what point you choose on the terminal side. Now that's a fascinating claim, and I hope to show it to you now or to prove it to you now. So in order to prove it to you, let's choose a random point other than the origin on the terminal side of this angle theta that is in standard position. Let's choose this point here. Let's call it point P. All right, let's say point P has coordinates x comma y, and let us draw the perpendicular to the x-axis from point P, creating a right triangle. Let's call this point here Q, where the perpendicular meets the x-axis, and of course we have the origin. Let's call that O. So we have a right triangle POQ. Notice with a right angle here, 90 degrees, angle theta, and of course our third angle there. Okay? Now, let's choose a different point on the terminal side, something other than P, and of course other than the origin. How about point, let's call it P prime, just a different point on the terminal side. So here's P prime, and it has coordinates x prime comma y prime. And let's do the same thing. Let's draw the perpendicular to the x-axis. So it meets the x-axis at a right angle, and let's call this Q prime. Okay? Now, we have a different triangle, P prime, O, Q prime. All right, but notice that we have a pair of similar triangles. Triangle POQ is similar to P prime O Q prime. How do I know that? Well, look at this triangle. This triangle has, the smaller triangle has a 90-degree angle, so does the larger triangle. The smaller triangle has angle measure theta, well, so does the larger triangle, has measure theta right here. That must mean this angle here and this angle here must be the same. So these triangles, their angle measures are the same. That makes them similar. Now, they're not congruent because they're obviously not the same size, right? We got a bigger right triangle and a smaller right triangle. So these right triangles are not congruent, but they are similar. Now remember, r is the distance from the origin to the point that you chose. So let's call this r right here. This is r. Here, I'll highlight it in yellow, or maybe I'll just do a dashed line in yellow. This is r. It's the distance from the origin to the point that you chose. So this distance is r. Now, this distance here, now this is going to get messy here, so just bear with me. From the origin to this other point right there, this is, let's call it r prime. The distance from the origin to the other point we chose is r prime. Okay, that's r prime. All right, because we have similar triangles, that must mean that the corresponding sides are proportional. We learned that in earlier studies. Corresponding sides are proportional. In other words, we can say the following. We can say that y is to r what y prime is to r prime. Let me show you that. This side, or actually maybe I need to show you what I'm calling y, okay? For my smaller triangle, this is your y, that vertical distance right here. Maybe I should use a different color. Bear with me here. Yeah, this would be nice. All right, let's call this y. This is your vertical distance here, right? I can highlight this if you'd like. If it helps your vision. This is y, which would make this y prime that I'm highlighting now, the vertical distance. This is y prime. So what we're saying then is this side is to this side what this side is to this side. Y is to r what y prime is to r prime. This vertical leg is to the hypotenuse what this vertical leg is to this hypotenuse. That's because they are similar triangles. All right, that must mean, now watch this everybody, sine of theta, sine of angle theta, sine of this angle theta. Remember, we already defined what sine of angle theta is. It's defined to be y over r, isn't it? Sine of theta is y over r. But y over r is the same thing as y prime over r prime. So look at that. I proved it. Sine of theta, the function value, sine of theta, will be y over r. That's using this point, which is going to be equal to y prime over r prime. That is using this point. So whether you use this point or p prime, it doesn't matter. They're going to be equal. Okay? So when we're talking about angles in standard position, and you need to find the 6 trig function values of that angle, this is the whole point. Use whichever point you want on the terminal side of your angle, as long as it's not the origin. Choose whatever point you want, and you should get the right answer. So make sure you have this conclusion in your notes, right? So that when you look at this diagram later, you're like, I don't want you to think like in a few weeks from now, like, what in the world were we talking about? It's right here. This is the conclusion. We can find the 6 trig functions using any point other than the origin on the terminal side of an angle. All right, check out this example. I like it a lot. Find the 6 trigonometric function values of an angle in standard position if the terminal side is defined by the equation x plus 2y is equal to 0 and x is positive. Okay, so I suggest you and I draw a picture. Now, this equation that they've given us, x plus 2y is equal to 0, can be rewritten, if you like, in slope-intercept form. Remember, y equals mx plus b form. So I am going to rewrite this equation in slope-intercept form. There. So we know that the terminal side will be found by using the slope negative 1/2. So let me show you exactly what that would look like. If this angle is in standard position, that means the vertex is at the origin and the initial side's on the positive x-axis. And the slope is negative 1/2. Now remember, slope is rise over run. Now watch this, please. This is very, very important. I am not allowed to go up 1 and to the left by 2. And so if I went up 1 and to the left by 2 like that, up 1 and to the left by 2, then that means the terminal side would be over here somewhere, right? That would be going up 1 and to the left by 2. Now the problem with that is, now that's a negative slope, right everybody? Up 1 to the left by 2, that's a negative slope. Everything seems to be okay, except over here in quadrant 2, x values are negative. And they told me that x values for this problem are positive. So although a negative 1/2 slope does mean you can go up 1 and then to the left by 2, we must not do that here because they explicitly said positive values for x. So let me not go up 1 and to the left by 2. Can I erase that? Let's see. Yeah. All right. So let me erase that very neatly. Let me go instead down 1. Now watch this. Down 1 to the right by 2, right? So it'll go through that point there. Let me just clean that up there. So it would go through like that, something like this. Down 1 to the right by 2. Down 1 to the right by 2. Rise over run. Rise over 1. Not rise over 1, excuse me. Rise over run. Okay? So then the point that it's going through is 2, -1. That's 2, -1 right there. So this is your angle. Okay, this is your angle theta. right? That's your angle theta. And the point here that you figured out that it's going through is positive 2, negative 1. Now that's important because we just figured out that x is positive 2, y is negative 1, and r is unknown. So let's find r. R is the square root of x squared plus y squared. And now we know what x and y are. So this is 2 squared plus negative 1 squared. So then r is equal to the square root of 5. Okay, r is equal to the square root of 5. Now that I know what x, y, and r are, we can now say what the 6 trig function values of this angle is. Okay, all right, let's do it. Let's build all of our answers. All right, so now sine of theta, we're naming our angle theta. Sine of theta is going to be y over r, so it'll be negative 1 over root 5. Now, you always want to make sure your answers are simplified. That includes rationalization. So we do not want a radical in the denominator. So if we rationalize, don't forget the way we would rationalize this, let me create some space here, is by multiplying the numerator and the denominator by the square root of 5. That's basically multiplying by 1. All right, so that would give us a simplified answer, a rationalized answer, as negative root 5 over 5. That would be the final answer for sine of theta. Cosine of theta would be positive 2 over root 5, but when you rationalize, you would get 2 root 5 over 5. Tangent of theta would be y over x, so to be negative 1/2. Cool? Now the last three will be the reciprocals, so cosecant of theta. All I'm going to do is reciprocate negative 1 over root 5, and you would get negative root 5 over 1, which is just negative root 5. Secant of theta will be the reciprocal of 2 over root 5, so it'll be root 5 over 2 and positive. Finally, cotangent of theta will be the reciprocal of negative 1 over 2, so it'll be negative 2. All right, so this is really great. You have to be very careful about what the equation is and be careful about what this says here, all right, if there is any restriction on your x values. All right, let's look at one last example before we wrap this lesson up. Find the values of the 6 trig functions for each of the following angles. First, we have an angle of 90 degrees. Let's do this one first. Let's draw a picture of what we have really quickly. Here is our angle of 90 degrees. Now, of course, this is a right angle. I called it theta. Now, we want to find the values of the 6 trig function values of 90 degrees. Now, we just proved a minute ago that you can choose whatever point you want on the terminal side of this angle. Choose whatever point you want. Choose 1/3 if you want. Choose, 7/9 if you want. Choose 500 if you want. Choose whatever point you want on this terminal side. Because we can choose whatever we want, why not choose something that might, be the easiest choice, that might make our work just that much easier. So in other words, I'm suggesting, since we can choose whatever point we want on the terminal side, let's choose the number 1. Obviously, this terminal side does pass through 1. So I am going to choose 1. Of course, the ordered pair there is 0, 1. Now, you don't have to use this point, ladies and gentlemen. You can use whatever point you want. But I'm just saying, I think that might be the easiest choice of all, okay? So here I go. Sine of theta, watch this. Sine of theta is y over r. Now keep in mind, if you're choosing 0, 1 like me, then x is 0 and y is 1. Maybe I should write that a little better. x is 0 and y is 1. Do you remember what r is? I know r is equal to the square root of x squared plus y squared, but didn't we define r to be the distance from the origin to your point? So if that is the definition for r, then r is just equal to 1. This distance here is 1. So then y over r would just be 1 over 1, which is 1. Sine of theta is equal to 1. Now cosine of theta is equal to x over r, so 0 over 1, which is 0. Tangent of theta, actually, you know what, I don't like what I've just done. I've used theta. Let's say exactly what theta is here. Let's not keep it vague. Our angle that we're talking about is 90 degrees. Sine of 90 degrees is 1. That's better. Cosine of 90 degrees is 0. Tangent of 90 degrees, remember tangent is y over x, so it will be 1 over 0. Uh-oh, this one will be undefined because you cannot divide by 0. Okay. Now the rest of the trig functions will be reciprocals. So cosecant of, let me write that better for us. Cosecant of 90 degrees is just going to be the reciprocal of sine of 90 degrees. The reciprocal of 1 is just 1. Secant of 90 degrees is going to be the reciprocal of cosine of 90 degrees. So instead of 0 over 1, you'll get 1 over 0. But notice that 1 over 0 would be undefined, right? If you flip this fraction over, you're going to get 0 in the denominator. So this is just going to be undefined, okay? And then finally, cotangent of 90 degrees will be the reciprocal of 1 over 0. So it'll be 0 over 1, which is just 0. 0 divided by 1 is equal to 0. Okay, notice that all of your function values are either 1, 0, or undefined. 1, 0, or undefined. Also, please notice that this is a quadrantal angle. 90 degrees is a quadrantal angle. 90 degrees is a quadrantal angle. And all of our function values are 1, 0, or undefined. Let's do this next problem. We have an angle in standard position whose terminal side goes through -3, 0. Now, -3, 1, 2, this would be -3 over here. So then the angle looks something like this, everybody. Standard position, so there's my initial side, and then my terminal side goes through, well, that was pretty sloppy. See if I can make that better. That's a little bit better. It goes through -3, 0. So then this is our angle right there. Okay? That's what we can call theta. That's what we can call theta. Now it does, I hope that you see that theta happens to be 180 degrees, right? Here we go. So let's do it. I hope you see that because they gave you the point, they actually gave you the point, x is -3 and y is 0. I'm just going to put x right above -3 and a y right above 0. Now, of course, what's missing is r, but don't forget how r is defined. R is the distance from the origin to the point on the terminal side. R is the distance from the origin to this point. So how many units is this? This is 3 units, right? So r is equal to 3. R is equal to 3. R must be equal to 3. All right, here we go, everybody. Sine of theta. Now, I'm using theta here because, I hope we all agree that it's 180 degrees. But in the previous example, they told us explicitly what the angle measure was. Here, they're not telling us the angle measure, but we can conclude that it is 180 degrees. So I'm just keeping it as theta. Sine of theta, remember, is y over r. Y over r, 0 over 3. 0 over 3, which is just 0. Cosine of theta is defined to be x over r, so it'll be -3 over 3, which is -1. I need to move my screen up a little bit here. Hopefully that gives me enough space. Tangent of theta, let's not forget tangent of theta is y over x. So 0 over negative 3, which is just 0. Now finally, the last three will be reciprocals. So cosecant of theta will be the reciprocal of sine of theta. It'll be 3 over 0, 3 divided by 0, which is undefined. Secant of theta will be the reciprocal of cosine of theta. The reciprocal of negative 1 is still just negative 1. And then finally, cotangent of theta will be the reciprocal of tangent of theta. Remember, it's x over y. Negative 3 over 0, right? So turn this over. Negative 3 divided by 0, that will be undefined. Please notice again that we're talking about a quadrantal angle in this example. The part A is a quadrantal angle, part B is a quadrantal angle, and all of your answers are 0, negative 1, or undefined. I hope you see a pattern here. Whenever we are finding trig functions of quadrantal angles, we're either going to get 1, negative 1, 0, or undefined. Those are your four options for function values of quadrantal angles. Now, I also want you to notice something else. This quadrantal angle has its terminal side on the y-axis. And which functions are undefined? Tangent and secant. Tangent and secant. Whenever a quadrantal angle has its terminal side on the y-axis, tangent and secant will always be undefined. Prove it. Okay, well, tangent and secant, both of them, are defined with x in the denominator. Tangent's defined as y over x. Secant is defined as r over x. Both of these functions are defined with x in the denominator. Okay, what's the big deal? Well, if a terminal side of an angle in standard position lies on the y-axis, the x value is 0. And if that 0 is in the denominator, like it is for tangent and secant, you will have a function value that's undefined. So, all quadrantal angles whose terminal side lies on the y-axis will cause tangent and secant to be undefined. Now, this quadrantal angle has its terminal side on the x-axis. Now, whenever you are on the x-axis, your y value is 0. Look, it's right here. Look at your y value. It's 0. Y is always 0 whenever you're on the x-axis. Which functions are undefined in this case? Cosecant and cotangent. Well, of course they are, because both cosecant and cotangent are defined with y in the denominator. Cosecant is r over y. Cotangent is x over y. Both of these two functions are defined with y in the denominator. And if the quadrantal angle has its terminal side going through the x-axis, or lying on the x-axis, I should say, then that means the y value will be 0, making these two functions undefined. Please add this to your notes. I think this would be really, really helpful. If the terminal side of the quadrantal angle lies along the y-axis, then the tangent and secant functions are undefined. If the terminal side of the quadrantal angle lies along the x-axis, then the cotangent and cosecant functions are undefined. The last thing I'll leave you with is maybe a table of function values for quadrantal angles. These are quadrantal angles: 0 degrees, 90 degrees, 180 degrees, 270 degrees, 360 degrees. Of course, there's many, many more, but these are the main ones. So these are different theta values. And up here we have sine of theta. So for the first row, it'll be sine of 0 degrees, cosine of 0 degrees, tangent of 0 degrees, and so forth. Okay. Now we just figured out all 6 trig function values for 90 degrees. We just did that in an earlier example. We also know that the function value will be undefined the function values for tangent and secant will be undefined if the terminal side lies on the y-axis. The terminal side for 90 degrees lies on the y-axis, and the terminal side for 270 degrees also lies on the y-axis. That means for 90 degrees and for 270 degrees, tangent and secant will be undefined. 0 degrees, 180 degrees, and 360 degrees all have their terminal sides lying on the x-axis. That means for these three angles, these three quadrantal angles, cotangent and cosecant will be undefined. All the other function values will either be 1, 0, or -1. Now, to help you fill this table in, I suggest you take the time to show a picture of what 0 degrees looks like, very similar to how I did it earlier a few minutes ago for 90 degrees. Draw a picture of 180 degrees. Actually, that was the previous example as well. Draw a picture of what an angle in standard position for 270 degrees would look like. And remember that you can choose whatever point on the terminal side that you'd like. So if you allow me to encourage you to choose 1 or -1 on the terminal side, and then you can find the values of the 6 trig functions. We already did this for 90 degrees, and we did it for 180 degrees in the previous example. So you can follow that format for 0 degrees, 270, and 360. Hey, by the way, 0 degrees and 360 degrees are coterminal angles, so they're going to have the same function values. So the first row and the last row will be identical. Here is our table with all of the function values filled in. Notice that you have nothing but zeros, ones, -1s, and undefined. Again, if you need help filling in this table, remember that you can always draw a picture of the angle like we did for 90 degrees. Go ahead and choose 1 or -1 on that terminal side and generate your trig function values. All right, remembering that sine of theta is y over r, cosine is x over r, tangent is y over x, and so forth. This table is really, really important. You want to make sure that you have it written down correctly in your notes, and you want to keep it handy for reference. This concludes our lesson. I hope you learned a lot. I hope you took really, really good notes. I'll catch you later.